Oh, hello everyone. Good morning. We'll go over this problem right here. Um, this is number 20. This is for my finite math class, and this is number 26. Um, now, the following table provides data on three popular protein supplements. Now we have 18, 2, 80, and decimal, and the cost is 0.5. So we have 18 grams of protein for this designer whey or whey, whatever they call it. We have 2 grams of carbs, and we have like 80 sodium milligrams of sodium, and it costs 50 cents. And we have so on and so forth. The main idea, the way to set this up is just to do like 18x plus 32y equals, well, um, let's see. Now, what we're asked to find um, the amount of designer whey and the amount of muscle milk, and so you are thinking of combining designer whey and muscle milk to obtain a 7-day supply uh, that provides exactly 398 grams of protein and 94 grams of carbs. Okay, how many servings of each supplement should you combine in order to meet your requirements? Now we have designer whey here, muscle milk here. Now this is pure whey. Um, okay. Now let's see. Now pure whey contains more protein, a few more carbs, a little more sodium, and is a little bit more expensive than the designer whey. Now the muscle milk is expensive. It has a good deal more protein, a lot more carbs, uh, a lot more sodium, and it's more expensive. Okay, so we have this table right here with this data in it, and I won't read off the data any, just piece by piece or anything. But now we come down here. Now the idea is to do like 18x. Now let's see, how do we get the 32 grams per serving? Let's see, it's 32, we claim it that it's 32 grams per serving. Uh, no, the designer whey is 18, in protein, it's 18 grams per serving. Oh, okay, we want, oh, he's rearranging the table. Okay, so he's put protein in rows. So the protein is 18, 32, 24. Um, but we don't want the whey. We just sort of we want the whey, but we want the designer whey. We don't want the pure whey. Okay, so we ignore the pure whey and just do the designer whey. So for the pure whey, we ignore it and we just do the designer whey, and we instead of going down, we go across. So 18, 32, 18 grams per serving, 32 grams per serving. And then for carbs, we go down. We turn the down into the across direction. 2 grams per serving, 16 grams per serving, and then 50 cents and $1.60 go here. Now, I don't. Okay, I guess they just found it easier to read that way. Then we just set up a matrix. Okay, once that was kind of the weird part. After this, we set up the matrix. We get 18x plus 32y equals 398. And we get 2x plus 16y equals 94. Now we have these two things here. Now guys, once then you just do linear algebra like we've been doing in the previous videos. You'll get, now we let x stand for the designer whey, and we let y stand for the muscle milk, and you wind up getting these two numbers here. For this example, we get 15 and 4. So now but now here's the deal: we got to go back and get the cost. So it's now we got 15. X is 15, and 15 goes with the designer whey, and 4 goes with the muscle milk. Now the designer whey wasn't that expensive; it was the 50-cent guy right here, and the muscle milk's expensive because it's already prepared for you, and it's got the stuff. It's probably more. It's already beefed up. So 15 times 0.50 plus 4 times the more expensive $1.60 for the muscle milk. So we'll get $13.90. That'll be the cost. Now, so the solution, we'll need to mix 15 servings of the designer whey and 4 servings of muscle milk for a cost of $13.90. So what have we just found here? So the original question was, we were thinking of combining designer whey and muscle milk to obtain a 7-day supply that contains exactly 398 grams of carbs and 398 grams of carbs and okay, so had to pause for a second. So we have 7-day supply. Yeah, we wanted 398 grams of protein and 94 grams of carbs, and we wanted the 7-day didn't really kick in. We didn't really use that, but yeah, this problem was a little harder, and we had to we wanted to combine it. Now we only wanted designer whey and muscle milk. We didn't want anything to do with pure whey. Okay. So yeah, that was a little bit harder. But anyway, yeah, if you had a little difficulty with that one, I understand. So the trick was to sort of transpose the table and get rid of the pure, and and you'll have your stuff. And go ahead and put the 398 here because that's what they called for. For the protein, well, the 398 for the protein, and the 94 for the carbs. That's what they called for. And then here's your cost per serving for the designer and for the muscle milk. And yeah, okay. You should get everything organized. Now, when you set up the linear equation, you set it up for the amount. The cost doesn't really go directly into your linear equation. The cost is what you plug into at the very end of things. Okay. So yeah, that's pretty cool. Now, if you number 27, okay. Let's say that we have designer, muscle milk, and pure. And what do they want? You're thinking of combining designer and muscle milk to obtain a 7-day supply that gives you 594 protein, 178 carb. How many servings of each supplement should you combine in order to meet your requirement? What will it cost? Let's see. And now the cost, we do that at the end. That's kind of separate. So, and I mean, I would like to have this in front of me. I'd rather not write all this out. You do it just like you did the last one, guys. I may skip over this if they don't. Is that just a tutorial? Okay. Well, let's see. What you'll do is you'll just sort of set up the table again, and you'll go through like you did before. Like last time we went down. If we wouldn't have had this other prettier table in front of us, how would we have done it with the nastier, not so nice table? Well, we just did an 18x plus 32y, and that would have equaled the 398 that they wanted for the protein. You got to go. We'd had to went down, but that's not the end of the world. and then now we'd had to done 2x plus 16y, and that equals 94 for the carbohydrate. And then there's your two equations, and then you'd find your protein and carb, and then okay, and you'd find protein and carb. Let's see, yeah, and well, 18x. So X is the number. Actually, X is sorry guys. X is designer whey. Y is muscle milk. Um, so X and Y don't have anything to do with protein and carb. X is designer whey. Again, Y is muscle milk. I got off my hinges there. I had a little. My brain had a blank moment there. Um, so you don't really. It's not about finding your protein and carb. It's about finding your designer and your muscle milk. So X is your designer. Y is your muscle milk. So 18X plus 32Y. The 18 is your the 18x plus 32y, and then the 2x plus 16y. You'll solve those. X would be your designer, y be your muscle milk, and then you'll plug those back in to get your cost. Okay, and let's see. And you kind of do all these sort of like that. They all go sort of the same way. And I threw in a smattering of these just to give you guys some real world problems. Like on number 30 here, you let X be the number of shares of HES, the Hess Corporation. I had my buddy, he used to work for Hess. And then the number of shares of XOM, ExxonMobil. I don't think he ever worked for Exxon, but anyway, you'll just make a table like this one here, and then you can do like a, let's see, in a 3 month period, the stock went down from 80 to 64. I don't know if we even, let's see, so 80 to 64, that was in 3 months. And then, so 80 goes here, 64 goes here. Now that was for Hess. So that's in the Hess category. Hess is X, let's say, and ExxonMobil is Y. And then ExxonMobil goes from 96 to 80. So put that here. And then you get, if you plan to invest a total of 24 grand 800, you're probably not going to be happy, but let's say you put in 24 grand 800 and now you're down to 20,320. Well, here you are. But now you just solve these equations, and you would be greatly benefited to divide out, like divide by 16, and divide everybody by 16, and that'll cut these guys down to size, right? You got to divide every term by 16 anyway, and then you got to kick back up and multiply every term by 5. Well, multiply every term by 8 on the first equation, every term by 5 on the second equation, the LCM, and you can cancel some 40s and solve it, and you'll get your Hess and you'll get your ExxonMobil. You'll find out how much you got. You'll find out how the amount of shares you bought, which is going to be your misfortune here. Let's see. But anyway, yeah, TD Bank. I don't own very many. I've done a little business with TD Bank. It's not been any heavy business. You do it like you did at the previous problem, guys. I would spend like 3 or 4 hours on this. I wish it would just give me the solutions. I've done these kind of problems quite a few times, but during the first quarter of 2015, we're probably not going to use the 3 month idea. But TD Bank, it costs a stock, which I'd be willing to invest in. It costs $45 a share and is expected to yield 4%. Well, no, I'm not peddling any ideas. Don't don't have anybody come back and sue me, guys. Just don't. I don't endorse anybody, so let me back off that. But no, it's okay. Sorry. Back off that. So during the first year of 2015, TD Bank stock cost $45 a share and was expected to yield 4% per year in dividends. Well, I don't want to come off like I'm shilling for anybody. I'm not. While CNA Financial Corp stock was $40 per share and was expected to yield 2.5% per year in dividends. If you invested a total of $28,000 in these stocks and expected to earn $862 in dividends a year, how many shares of each stock did you purchase? Okay, now what you do, you invested $28,000. So let's just say let X be TD Bank. And the only reason why I said I was partial to TD Bank, I'm familiar with it. That's all. So X, let's just say X is TD Bank and Y is the other guy, and it may be just as good. I'm just not familiar with it. So X plus Y equals 28,000. That'll be your first equation, and your second equation will be, well, you'll do the rates, and that'll be. Now, TD is, so you'll do 4%, so that's 0.04x plus 0.025y equals 862. And you'll solve it from there. And remember, last time I showed you how to adjust those decimals, you'll need to adjust. So again, your second equation is going to be 0.04x plus 0.025y equals 862. That's your second equation. And if you forgot what your first equation was, your first one was easy. It's just x plus y equals 28,000. So, and you'll set, now your first equation you won't need to tweak yet. Your second one you'll need to tweak it. You'll need to multiply everything by 100. Wait, no. Actually, you'll need to multiply everything, since you got that nasty 2.5, which is 0.025. You'll have to multiply everything by 1,000 to scoot 3 places over, and let's see, that 4% will turn into, so you'll have 40x plus 25y equals, and if you multiply 862 by 1,000, that's 862,000. So 40x plus 25y equals 862,000 would be your new second equation. And then from there, you would do the linear algebra to solve your first equation and your new second equation. And I'll leave that to y'all. We could go on all day, but that's the idea. People beg me for real world problems, and I gave it. I figured I'd furnish that. Let's see. Well, and infly mini question details. The local sushi bar serves an ounce of raw salmon. Ooh, well, every man to his own, or every person to his or her own. Serves 1 ounce of raw salmon. I guess that's good protein. And 1 1/4 pieces of raw tuna. Okay. A customer's total intake of protein amounts to 3 1/2 ounces after consuming a total of 7 pieces. Okay, how many of each did the customer consume? Well, all right. So we got the local sushi bar serves 1 ounce, 1 ounce pieces of raw salmon, and 1 1/4. That's 1.25 ounce pieces of raw tuna. Now the salmon, the 1 ounce will give you 50% protein, Now, 1 1/4 ounce of raw tuna will give you 40%, but we had to have more of it though. If you divide 40% by 1.25, what will you get? Really, the tuna, you don't really get as much mileage at all because you have to, not only do you just get 40, you have to divide 40 by 1.25. The 1 ounce, just 1 ounce will give you 50. Here, 1.25 would just give you 40. So let's see if we can get away with not even doing linear algebra. So if we divide 40 by 1.25, is that 32? Was off. 32. So really, just 1 ounce, just plain 1 ounce of raw tuna will give me 32% protein. So what the salmon gives me 50 of, the raw tuna gives me 32% of. Not 40, but 32. Now, okay. So now if a customer's intake, whatever the customer eats, he eats 3.5 ounces of. Now, and he eats 7 pieces of. Okay. So now how many of each did the customer consume? Fractions are permitted. If there is no solution, enter no solution. If there are infinitely many solutions, enter infinitely many. Guys, it says infinitely many solutions. It says it could go. It could go. Basically, this means it could go a whole bunch of ways. I don't know if I like this problem. So 50% here, 32% here. Let's just convert. Let's turn this into 1 ounce. So x plus y. Well, let's see. The amount of tuna, x plus y equals, well, we know x plus y equals 3.5, right? Well, let's just, so ounces plus ounces. If I convert out, well, let me just leave it. X plus y equals 3.5. Okay. But let's just leave it 1 1/4 for now, okay? Let's just stay at 1 1/4. And if we stay at 1 1/4, x plus y equals 3.5. Oh, the protein is 3.5. Okay. So the protein is 3.5. 1 ounce pieces serves 1 ounce pieces of raw salmon. Okay, 50% protein, and 1 1/4 ounces. So x plus y, we'll have to leave it 1 1/4, guys. Sorry. So let's just leave it. I'm just going to leave this as 1 1/4. So 1.25. So x plus y equals, what I said was true earlier, but I don't know if it's useful. So x plus y equals the amount of, well, let's see. As far as protein goes, it's going to be 1x plus, wait, no, x plus y, x pieces. Let's do pieces first. That would be a whole lot easier. X plus y equals 7. This is kind of rough. 1 ounce pieces. So we have 1 ounce. This is kind of rough. Okay, for the protein, 50%. Okay, 1 ounce is 50%. So as far as the ounces go, now 1 ounce, we'd have to multiply 1 ounce by half. You know what? No, I actually had it right all along. I need to multiply 1 1/4 by 40%. So multiply 1 1/4 times 40. Well, I don't know if I had it right all. Well, 1 1/4 times 0.4 is 1/2. Oh, we do it this way. Okay, so 1 1/4 times 0.4. 1 1/4 ounce will give you 40% protein. So it's 40% protein. per 1 1/4 ounce. What's going on here is, let's go to Word. So we get 40% protein, which is 0.4, times, and that's 40% protein per 1 1/4 ounce, or 1.25 ounces. And let's put the 0.4 up top just to be neater about it. 0.4 protein. Whoops, not, wait, yikes, that's bad. So I see what's going to happen here. So we got 0.4 protein per ounces. Well, it's 0.4 protein per 1.25 ounces times 1.25 ounces. No, it's 0.4 protein per ounce times 1.25 ounces. Sorry. And then this problem was kind of worded weird. And then yeah, I'll be honest, this problem, I had to wrap my head around this one. And then, come on now. And then plus, so this, and then the ounces cancel each other out. And then 0.4 times 1.25 is decimal 5. Plus 0.5. Now this takes care of the tuna. Now the salmon is just 0.5 protein per ounce. Okay, the hard part to understand was the proteins per ounce for the tuna. Protein per ounce times 1 ounce. Okay, and I'm gonna have to make the font smaller. It's too big for me to work with. Okay, so we got that, and I forgot to close that off, and I don't want that print. Oops. 0.5 protein per ounce times 1 ounce. Okay, and then but guys, what's going to happen here is I'm going to get 0.4 times 1.25. That's going to just give me, that's just going to, the ounces can't kill each other or cancel each other out, and I get 0.5 ounces here, and I get 0.5 ounces here, and multiplication by 1 is of no real avail. So I get 0.5 ounces plus 0.5 ounces. But now I need, oops, I forgot my x. I need my x here, and I need my y. Let's just say here. Wait, no. Sorry. I need my y, let's say here, because there's a variable y. Oops. It would be nicer, it'd be kind of cleaner if I put my x here. It just looked better. Okay, and I need my x here, and I need my y here. And oops, not ounces, protein. 0.5x protein per, or it's grams of protein, right? Technically, I should say grams of protein, because it doesn't make sense to just say protein, but y'all get the idea. It's grams of protein. But anyway, so 0.5x grams of protein plus 0.5y grams of protein. Okay, so I've cleaned that up, right? There's my first equation. That was, ew. That was sweaty. Yeah, okay. And that's 0.4, 40% protein per ounce. Okay. Now, um, now, okay. Now, 7 pieces are consumed. Okay. Now okay, 7 pieces are consumed, but now I'm not done with the. We're told that 3.5 ounces of protein are consumed, right? So 3.5 ounces of protein are consumed. I'm told that 3.5 ounces of protein are consumed. And yikes, this should be protein per. This should be yikes. This should be protein per. Okay, no, and I'm right. We're good. We're good. It's just ounce pieces of salmon. Um, it's ounces of protein. There's ounces of protein versus ounces of salmon. You got to watch out for the ounces. Ounces has a, and down here I need to say ounces of salmon. Protein per ounce of salmon. Okay, and then I need to put my equals, and then here I also need ounces of salmon because ounces is hollow. Ounces of what? Ounces of salmon, and then 1 ounce singular of salmon. And I'm sorry that the text wrapped, but if I make the font much smaller, it's going to get too hard to read. So ounces of salmon cancel each other out here, and also here and here. Well, I misspelled salmon here, didn't I? Okay. So, but anyway, we do get, okay. So, and then ounces of protein. So, and I should say ounces of protein, and the 0.4x would really go up here, but it's okay. We get the idea. I mean, everything I said is correct, guys. I just was incomplete, kind of, or I was kind of helter skelter. Let me make it unhelter skelter. Yeah, and it's okay to be out to the side, but it would be neater and petiter if I put it up here in the numerator. So 0.5 ounces of protein per 1 ounce of salmon, and per 1 ounce, well, not ounces, ounce of salmon. Okay. And that's going to equal, we were told that the guy or lady who ate here had 3.5, that he or she ate 3.5, or she consumed 3.5 ounces of protein. Okay. That's kind of messy. So to summarize, the lady or guy who ate at this bar, sushi bar, so they 0.4x. Let me get rid of the of there. They had 0.4x ounces of protein over per 1 ounce of salmon times 1.2. No, this is tuna. Oops, not salmon here. This is tuna. Okay, just please. Oh man, Word is freezing. I did a text rep, and now Word doesn't like me. Okay. Uh-oh. Let me get out of the commander. So this should be tuna here, guys. So Tuna, tuna. And this should be tuna. Come on. Come on. Tuna. And I better make this bigger. So, no, actually, I don't like that either. Okay, I'd prefer it that way. Okay, so finally, guys, after much struggle and after some heartache, here's my first equation. So here's my first equation. and I may edit this video. I don't know. If you're watching the video, I've already edited anyway, so it doesn't matter. So here's my first equation, and okay, and I put it in red here. So it took me a long time to get this thing straight. But really, I need to clean it up though. So ounces of tuna will cancel each other here and here. Ounces of salmon will cancel each other here and here, because there's 0.4x ounces. There's 0.4 ounces of protein per ounce of tuna, but we eat x is the amount that the person eats at the restaurant. So you multiply by x. We stick the x into the equation, but and then now we multiply by 1.25 ounces of tuna to adjust, and then we add. So we put the plus sign here. And maybe the plus sign will be better served out here. And then we have 0.5. Now 0.5 ounces of protein per 1 ounce of salmon times 1 ounce of salmon. Now the ounces of salmon cancel each other and just leave ounces of protein. Now we're told that all that added together and equals, notice all that's left is ounces of protein, 0.4x plus 0.4x ounces of protein plus 0.5y ounces of protein equals 3.5 ounces of protein. That was hard. But now this is my first equation, but it's awful messy. It's awfully messy. So what we need to do is, let's clean it up. So this is the first equation. How about unorganized? Let's organize it. So I need to get the organized first equation, and the organized first equation would be this guy. And let me make the font pretty big. There we go. So here's my true first equation. Oh, I've made it pretty, right? Here's my true first equation. So 0.5x protein, but we don't want the word protein hanging in there. That's just kind of gaudy, and it makes it feel like we got something else in there to solve for. So x is going to be the ounces of protein that comes out of the tuna. X goes with the tuna protein. Y is going to be the amount of protein that we get out of the salmon. So that's our first equation. That was kind of rough going, but we got there. I don't really love how this was worded, but I've already assigned it, and I've kind of put my feet in the fire. Now, guys, I may not edit this video. It's good maybe that I'm struggling a little bit with this one, just so I assigned it. Maybe it serves me right for assigning such a bad problem, or badly worded. Now, we eat 7 pieces. So, that's just x plus y equals 7, right? That's all that is. That's it. Pieces is trivial. So there's not much you can say there. That's just the second equation is so easy. The first equation was so mean. The first was mean, second's nice. That's just x plus y equals 7. And let me get it to the left there. But hey guys, look at there. Look there. If you multiply the first equation by 2, but if from the last video, you know, if we multiply multiply the first equation by 2, we will get the second equation. We don't really have 2 equations at all. And we don't have 2 equations at all. Not at all, right? We have these 2. It's x plus y equals 7. And indeed, our solution would be the infinite set like in terms of x, it would be like the set x comma y, such that it would, well, in terms of x, it would be the set like x comma y would equal 7 minus x. Or in terms of y, it would be this. It would be what? Well, it would be 7 minus y would be here, and the y coordinate would be the plane coordinate, and then like that. So from the last video, but anyway, this is sort of going a bridge too far, but I just wanted you guys to see, this is how you'd write out the infinite set of solutions. But, and this would be the line y equals 7 minus x. But anyway, I just wanted you guys to see that. So I'd like to move into 3D systems now, if I may. Let's see. 45. A system of 3 equations and 2 unknowns corresponds to 3 lines in the plane. Describe several ways in which these lines might be positioned. They can be parallel. The 3 lines intersect at 3 different points. That could happen. You could just draw 3 lines. None of them have the same slope whatsoever, and they don't. That could be. 2 of the lines are parallel, but the third guy is not. That could happen. I think that guy's devoted to mowing here all day. I don't know what else is left to mow. 2 of the lines are the same. Now this cannot happen. 2 of the lines are the same, and the third line intersects in a single point. Let's see. A system of 3 equations and 2 unknowns. We've got 2 unknowns. Let's see. That cannot happen. 2 of the lines are the same, so they overlap, and the third line intersects it in a single point. Well, to me that could happen. I don't see what the problem is with that one. Now, 3 lines intersect at a single point. Now this can't happen. Oh wait. Oh, I didn't read all the questions. Sorry. Yeah, all these could happen. Yeah, but I didn't read all the question. Describe several ways in which these lines might be positioned. No solution. Oh, key word. No solution. Okay. If you have no solution, 2 lines are parallel. That is a good example of no solution. See, 2 of the lines can be parallel. That would ruin it. If they're all parallel, that would ruin it. And if the 3 lines intersect in 3 different points, forming a triangle, that would that ruin things? Yeah. If the 3 lines intersect in 3 different points. If 3 lines intersect at 3 different points, forming a triangle, that would... Yes, because, guys, if this happens, now this isn't paralleleness, is it? But why is this a problem? This is a problem because to have a solution, you would have to have a solution, you would have to have all 3 intersecting at a point. But that can't happen if you have 3 lines intersecting at 3 different points. Okay. If the addition or subtraction of 2 linear equations, if you get 18 equals 18, that's going to be infinitely many solutions. The 2 graphs are equal. Now, if you get 0 equals 27, you have no solution. You're parallel. Okay. But anyway. So let's move on to 3D systems. And I'll try to also show you how to set it up in matrix form. And one thing I wanted to talk about as well, if they ever give it to you in messed up form, like if let's say they give you x plus y equals 7. Let's say they give you, well, I meant to go to fun. If they give you x plus y equals 4, and they give you x plus 3y or no, let's say I want a messed up one. One that we can solve, probably, but one that's out of order, let's say. Let's say they give me y minus 5 equals 2x. You're going to need to rearrange this second guy, right? Because we can't solve him in this form right here. We'll need to rearrange him. You'll want to rearrange, like y minus 5 equals 2x. I don't know why I erased it. Y minus, well, I must have got clumsy. But y minus 5 equals 2x. Rearrange this. Like, go ahead and just recopy. So copy back, and you'll get x plus y equals 4. That was fine. But then you'll need to recopy this guy over here. Now, and the way to do that is just to rearrange. Let's just say I Benedict Arnold 2x, and I get negative 2x, and I leave the minus 5 over there, and I get neg 2x minus 5, and no, sorry. I don't leave the 5. I get neg 2x, I leave the y over here, and I move the 5 over here. I jump the equal sign, right? So 2x jumps across and becomes neg 2x. Now y stays here, and I get plus y, and then the neg 5 jumps across, and I get positive 5. Remember, you change negativity if and only if you jump across the equal sign. So the y stayed plus y because it stayed on the left side. The 2x jumped across to the left and became neg 2x. The negative 5 jumps across to the right and becomes positive 5. So that's going to be, we want to write the second equation as neg 2x plus y equals 5. So here we go, right? We've rearranged it into the order we want. So rearrange when necessary. That's a big deal, right? And in 3D systems, that'll be a big deal. Okay, so now what if now I'll move along down the highway, and one thing, and now I told you last time, I saved you the trouble, but like I told you, like if you have two equations, like x plus y equals 4 and x plus y equals 5, like if you ever have x plus y equals 4 and x plus y equals 5, you'll have no solution, right? Because you can't have x plus y equals 4 and x plus y equals 5 at the same time. You have the same left side equal to two different right sides. No solution. Now, if you have x plus y equals 4, and you have like 3x plus 3y equals 12, now that's infinitely many solutions, because the second equation is just 3 times the first one, right? So you don't really have, it's just the same equation in disguise. So that's just a recap of the two pathological cases. Now you can have some funny stuff. What if you have x plus y equals 4? What if they just give you x equals 2? Well, now in that case, what you have is x plus y equals 4 and x plus, there's two things you can do. In that case, you can just plug 2 in and be done. You just have 2 plus y equals 4 and y would equal 2. That's sort of the easy situation. If you're truly retentive, like if you want everything perfect, yeah, you could say you could say x plus 0 y equals 2, and but that's kind of getting a little bit out there. That's kind of getting a little bit too maybe strict. But anyway, you could, if you insisted, putting 0 y there. But it really, 0 y means you don't have y, right? That's just x equals 2. You can ignore y. Anytime we ever say that y equals 4, subliminally, we say 0x plus y equals 4. And that does come in handy sometimes, but that just means y equals 4, right? Yeah, there's no point in being, sometimes we don't want to overkill it, right? We want to keep it simple. But it does, sometimes I will on a rainy day use 0x plus y equals 4, or the likeness of that, or the analogous situations. But anyway, just keep a heads up for that. Now, let's go, let me go to web, let's look at 3D systems. And, well, to do 3D, let's say, now 3D can get overbearing sometimes. So I'll go into 3.2. And let's see what 3.2 has to say. Oops, I meant to go to view. So let me go into 3.2. And now, guys, they ask you to you can just do this the same old way we've been doing it on 3.2. You don't really need to do a change of the guard. And number 3 is infinitely many solutions. Number 4 is no solution. Number 5. Now, number 5, they give you 3 equations. But if you have, I claim with 2, it is my claim that if you just have 2 letters like X and Y, you're in 2D space. What does it mean to be in 2D? When I say you're in 2 dimensions, it means you just have 2 letters, X and Y, right? You shouldn't need 3 equations. You should just need 2. And that sounds bold, like I'm being bold, but you should just need 2 equations. Like if I add the first and the second, like 3x plus, like we always have been doing, 3x plus 1x is 4x, and the y's cancel. 0 plus 1 is 1, 4x equals 1, x is of course 1/4. And then I can plug 1/4 into the first equation. 1/4 plus y equals 1, y would be 3/4. There I go. 5 is overblown, right? You just do it like we've been doing it in the previous videos. This section, it starts out being way overblown. Now, I need to show you how to do matrix stuff, but let's not overblow things, okay? Again, all these are overblown. You only need 2 of these equations, guys. Now, when you're in 3D with x, y, and z, you need 3 equations. It's true. But when you just have x and y, you only need 2 equations. Now, now if you have an equation, now be careful. With number 6, it is different if you have a guy who's causing a contradiction. What the third equation can do to you, the third equation cannot cause infinitely many solutions, but it can cause a contradiction, because that is a problem. Like if you have a third equation that's going to cause a contradiction, then you have a contradiction, and it has ruined things. Like it can ruin the food, so to speak. Like if we do the first and third equation, if we get 2x, the y's cancel, and we get 2x equals -1. So that feels like it ought to be -1/2. And if I plug -1/2 into the first equation for x, we'd get y equals 1/2. And that's good. The first and third equation would push through just fine. But let's plug it into the second equation. So x is a -1/2 and y is a +1/2. That's not going to work. We're not going to get 8. No solution. So in a way, you do have to check all 3 equations. So in a way, I'm on you ever heard the old saying, take it back, take it back? I'm gonna, like the person would say when he or she was a kid, I'm gonna have to take it back, because the third equation might cause no solution. So you do have to check it. Number 5, I got lucky because the third equation was real pretty. It conformed to the other 2, and I didn't have to worry about it. But yeah, the third equation might cause no solution, so I'm going to have to take it back. You do have to watch that third equation because it might cause no solution. That's a so yeah. When you just have x and y, you do have to watch the third equation because it may cause no solution. Now, guys, I have intentionally avoided row echelon, but I'm gonna have to pay my dues and do it. But I want to do row echelon the right way. I've kind of avoided it like everything with these. I could have done row echelon, and like here's the deal with row echelon. And I'll use what they have here. And here's the idea with row echelon. If you write it out, if I wrote it out on Word, it would take me 20 minutes to do a single problem. But you write out the coefficients. You don't write the x's or y's, or any variables. You write out the coefficients. So we have 1x plus 2y equals 1. So you go across the row, 1, 2, 1. Here, here, and here. And then on the second row, we have 3x minus 2y equals neg 2. So it's 3, neg 2, neg 2. And then on the third row, we have 5x minus y equals 1/4. So that's 5, a negative 1 understood, and 1/4. 5, neg 1, 1/4. So this is the alternate way to do it, and that's what I'm doing now, okay? And this is number 7. Now, is this the only way to do it? No, there's always a buku of different ways you can row echelon, okay? Here's the way they did it. Now you want to cancel things. You ultimately want to get like you want to pivot. You pay attention to the main diagonal. Okay. You want zeros. You want like a non-zero here, 2 zeros here. And then you want your other non-zero to be. You want a non-zero in row 1, column 1. You want a non-zero in row 2, column 2, and you want your last non-zero in row 3, column 3. So your non-zeros, like. You want a non-zero in your top left with zeros looking down below, a 0 here and here. You want a non-zero in the middle here, but with a 0 directly above and directly below. And you want a non-zero here, but now it's not necessarily promised what to be directly above you. Okay, that's the strategy, is where we end up here. So, and we're going to do whatever it takes to get there. Now, different people will do different things. Here's what they do. We got to cancel, see that 1, 3, and 5? We've got to cancel that 3 and that 5. Okay, so what we're going to do is we're going to multiply, what they do is they multiply row 3 by 4. They get rid of fractions. I don't blame them. Fractions are always nasty. So let's get rid of that 1/4. But to do that, you got to multiply the entire row 3. There's collateral damage. You got to multiply row 3 by 4. So you get 20, neg 4, and 1. And so there we are, right? And because if you multiply 1/4 by 1, if you multiply 1/4 by 4, you'll get 1. And that's good. That's what we wanted. But you also got to multiply 5 by the 4 and the neg 1 by the 4. And you'll get the 20 and the neg 4. So times 4, times 4, times 4, and we get this, this, and this. Okay, now, so bye-bye fractions. Now the next thing we do is we want to set these, like the 3 and the 20, up like pawns to be brought down to 0. We're basically setting them up sort of for the 0 slaughter. Now, I'm going to do row 2 minus 3 row 1. And we're going to put that in the new, and we're going to, whatever that turns out to be, we're going to put it into the new row 2. We're going to place that difference into row 2. And we're going to take row 3 minus 20 row 1 and put that into row 3. The new row 3 over here. We're going to take row 3 minus 20 row 1 and put that into this row 3 over here. We're going to take row 2, again, we took row 2 minus 3 row 1 and put that into the new row 2 over here. Why did we take row this? We took this old row 2 and we subtracted 3 times the old row 1, and we put that in the new row 2 over here. Why? Because y minus 3r1. Okay, we want this 3 here to die, to 0. And the easiest thing to pick on is 1. It's a lot easier to pick on 1 than it is to pick on 20, right? We'd have to we want neg 3 real bad. 3, the way to annihilate 3 is to use neg 3. But now, to turn 20 into neg 3, I'd have to multiply by neg 3 20ths, and that's nasty. It's valid, but it's nasty. I don't want to do it. So, but 1's easy to work with, right? So I multiply this whole row by neg 3, and then I add it to this row right here. So neg 3 row 1 plus row 2. We're saying the same thing, aka row 2 minus 3 row 1. So we get, now neg 3 times 1 is neg 3, plus 3 is 0. That's why we did this, and we put that 0 right here. But the collateral damage is if you multiply neg 3 times this guy, you have to hit this guy by neg 3 and this guy by neg 3. You have to multiply the whole row, the whole top row by neg 3. So neg 3 times 1 plus 3 is 0. That's why we did this thing. Now here's the collateral damage. Neg 3 times this 2 right here is neg 6. Neg 6 plus neg 2 is neg 8. Neg 3 times 1 is neg 3 itself. Neg 3 plus neg 2 here is neg 5, and that goes right here. You just put it in the corner where we agreed to put it. Okay, so there we go. So there's that, and we have done what we wanted to do. We have annihilated the old 3 to the 0 right here. Now the next guy in line for annihilation is the 20. Because you remember we want 0, 0 below the 8. Okay. Now we want to, again, now 3 is a nightmare to pick on. We want to pick on 1. Because we want neg 20. Neg 20 gets rid of positive 20. So multiply this whole row by neg 20 and add it to this row. So we get, now neg 20, so you got to multiply this whole row by neg 20 in an analogous fashion. Neg 20 times 1 is neg 20 itself, and neg 20 plus this positive 20 is 0. That's why we did this. And then so put that 0 right here. Okay. Now, and then now neg 20 times 2 is neg 40. This is the collateral damage. And neg 40 added to neg 4 is neg 44. That's just what we have to, put up with. And then neg 20 times 1 is neg 20 itself. Neg 20 plus positive 1 is neg 19. So put it right there. So there's that. Okay, now that's good. We've got 1, 0, 0, and that's all good and well. Okay. Now here's the dig. What I need to do now is I need to get rid of this. The strategy is to get a 0 here and a 0 here. So I need to get rid of this 2 and this positive 2 here and this neg 44 here. Now negative 8 is kind of negative 8's kind of weird. How would I do that? Well, let's do this. How about if I do 8 row 1 plus 2 row 2? 2 and 8. The least common may not be as friendly. Okay, here's what they did. I don't know if I would have done the same thing. Yeah, I guess it'd be okay. Let's try to avoid fractions, okay, guys? Let's do common multiple, maybe not least common. How about we do 8? If I do 8 times 2, I get 16. And if I do 2 times neg 8, I get negative 16. So let's do 8 row 1 so that 8 will hit that 2 there. And then 2 row 2 so that 2 will hit neg 8. And if we add them, we want to add them because they have opposite signs already. We don't want to subtract. They already have opposite signs. We want to add. So we do 8 times this row plus 2 times this row. And then we're going to put that up here, though, right? We don't want to mess with this. We want this. We love this 0, right? We don't want to mess with it. It would be a mistake to put this down here. We want to put it up here, right? We don't care about preserving this 1. We care about preserving these zeros here, right? That's what we care about preserving. We can always divide back and get 1. You can't divide and get a 0. So let's do it. Now, 8 times 1 is 8, plus 0 is 8 still. So 8 we have. Now that was collateral damage. Now 8 times 2 is 16. Plus 2 times neg 8 is 2 times neg 8 is neg 16. Well, 8 times 2 is 16, plus the product of 2 and neg 8 is neg 16. So we have 16 here, added to neg 16 here. 8 times this guy plus 2 times this guy, 16 plus neg 16 is 0. And we put that here. Uh-oh. We put that here. We don't put it here, remember. We put it here. So there we go. And again, just so we started here, we did 8 times this guy, which is 8, plus 2 times this guy, but that was just 0 all over again. Or 2 times 0 is 0, but 8 plus 0 is 8, and we put that 8 right here. And then the next thing, 8 times 2 is 16. 2 times neg 8 is neg 16, but they add a 0, and we put the 0 up here. So we got 8 here so far, and the 0 here so far. The motive, but that 0 here is why we did this. That 0 here on the step I just did, that's why we did this. So we've already done the motive step. Now we go back to collateral damage. 8 times this 1 is 8. 2 times neg 5 is neg 10. But if I add 8 and neg 10, I get neg 2, and I put it up here. So here's neg 2. So I have 8, O, neg 2, O, neg 8, neg 5, O, O, 68. Okay, I'm toast. I'm in trouble. I wanted 0, 0, 0 down here. Guys, if you ever do this on this very last row, it doesn't matter which row. You want to have a row of all zeros somewhere. Somebody needs to be all zeros. You never want to have that row that has the bad news bear is this row right here. You see this row that has 0, 0, 68? That means no solution. If it would have been 0, 0, 0, then I could have went up here and I would have divided both sides of this by neg 8, and I'd have gotten x equals 5/8. Y equals 5/8, and I divided both sides by positive 8 and gotten neg 1/4 for x. So x would have been, keyword would have been neg 1/4. Y would have been positive 5/8. If this would have been 0, 0, 0. But it's not 0, 0, 0. It's 0, 0, and somebody, namely 68, who's not 0. So that means I have no solution. Okay. If had this been 0, 0, 0, you would this second row, it's fine in and of itself. That's just saying neg 8y equals neg 5. Neg 8y equals neg 5. Well, that would be y equals positive 5/8. And 8x equals neg 2, divide both sides by 8, and that's x equals neg 2/8, which is neg 1/4. But 0, 0, 68 is saying, stop right there. Everybody's disqualified. That 60, you didn't give me a 0 here in this last thing here. It's over. Disqualified, invalid, no solution. Because what your row 3 is saying is that 0 equals 68. That's an absurd false statement. So it's no solution. Now, guys, you may ask, well, Jason, is this the way you just did it, or the way they did it, rather? Is that the is that the only way to do it? No, it's not. There's like a buku different ways you can do this. You can do this a buku different ways. You can do this probably thousands and thousands of different ways. Probably, actually, infinitely many if you use all the real numbers. This is probably one of the more efficient ways you can do it, though. Now, I wish they showed all the. Do they show all the details on all these, or not really? No, they don't, do they? I wish they. For me to write all these out. Now, this one had a solution. On this one, you would actually get 0, 0, 0. And let me see. Like I did it the old-fashioned way, but you can do it the row echelon way as well. But you guys, I mean, I've showed you how to do it the real way. You just solve it like you add the first equation to the second equation. Wait, no, you add the first to the second, not the third. And you get 4x equals 1, x is a fourth, plug a fourth back into the first equation, 1/4 plus y equals 1, y is a 3/4. So it's going to satisfy the first and second equation because that's who we used to get it. But what about the last equation? You have to check the last equation. That's where I should have been more careful. So I've got to go back and do number 5. So number 5, 1/4, is it true that 1/4 minus 11 times 3/4 equals -8? I need to check that. Is that true? So 1/4 minus 11 times 3/4, is it true that equals -8? And I was wrong for not checking that last time. Is that true? I dare say, well, yeah, it's true because they said so, but let's check it. 1/4 minus, well, 11 times 3 is 33/4. That's -32/4. That's -8. It's true. But I was wrong for not checking it because for all I knew, they may have given me something that's not true if I wouldn't have had the answer key in front of me. But guys, let me do it in row echelon form on Word. I've almost got to, or I'm not really teaching you anything. So let me do it the row echelon way on Word. Let me see. Well, no, I don't need to open up a new file. Let me just keep scrolling down. Okay, I hope it pastes right. Let me see. Keep source formatting. I guess that's fine. X plus y equals 13x minus y. Did it? Okay, that's good. Okay, guys, so we have this, right? Now, here's the dig. I want to make a matrix. Insert matrix. And what I can, if I want to make a matrix, let's see. Here's a 3 by, yeah, this is good. So I want to make a 3 by 3, and I need to create my little things over here. Okay. So I have x plus y equals 1, so that's 1, 1, 1. I have 3x minus y, 3, -1 equals 0, and then 1, -11, and then -8. So I want to echelon this guy. So what I want to do is I'm going to draw an arrow, and then I'm going to Control C, and what I want to do. I tell you what, you see this one, I'm going to do row 2. What if I do row 2? No, that's too much. I'm afraid the equation editor is bad to freeze. But obviously I could do row 1 minus row 3, right? Well, no. Let me do this. Row 1 minus row 3, and I want to put that in row 3. And what else do I want to do? I want to do 3. So let's just go ahead and do that. So let me do that. Row 1 minus row 3 and put it in the new row 3. So bye-bye. I want to get that 0 there, right? To get 0, to get the 0 in the 3, 1 entry. Row 3, column 1 entry. And that, when I'm referring to this entry right here, right? Row 3, column 1. So I do 1 minus 1 is 0. 1. Now be careful, I got to finish. 1 minus neg 11 is that's 1 plus 11 is 12. And 1 minus neg 8 is 1 plus 8, and that's 9. Now let's see. Okay, and now let me just go ahead. And multiply row 3. Well, no, let's see if we can hold all this in our head. Do row 3, row 1 minus row 2, and put in new row 2. I'm using bad English. To exterminate the 3, right? To get a 0, more specifically in row, what is that? Row 2, still column 1. Okay, but we're going to have to be careful. Now, if it's cool with you guys, I'm going to go ahead and triple all this stuff. So if I triple row, and I'll untriple it in a minute. I'll redivide it out by 3. If I untriple somebody, I divide them by 3. So that's kind of convenient. I've got all 1s up here. Really? Yeah, I do. That's rare. Okay, so 1, 1, 1 is now triple, triple, triple. So now 3. Now I've already tripled everybody, so I can just straight up subtract. 3 minus 3 is 0. Now 3 minus neg 1 is 3 plus 1. And 3 minus 0 is just 3. We're subtracting because the signs are the same. Now, but if you subtract a negative, you turn over, right? We subtracted neg 1, so we turned over. Okay. And now let's just redivide out. Let's just turn these back into 1s again. It served its purpose. Okay. This appears solvable. We're not done. We need to either show this has no solution or it does, right? Now, redivide. Let's just go ahead and divide row 3 by 3. And that's going to be, guys, anytime you can divide a row by a constant and stay clean, do it. So you'll get 4 and 3. 12 divided by 3 is 4. 9 divided by 3 is 3 itself. So there's that. But hey, look at there, look at there, look at there. These exact rows match. But rows 2 and 3 match. But row 2 and row 3 match. So subtract, so do row 2 minus row 3. Row 2 minus row 3, and put into row 3. So you're going to have Control C and Control V like that. Now, guys, okay, like that. So that's just up. 0, 0. Okay. Now row 3 has been annihilated. Okay. Now the 4 needs to survive. the one in, let's see, it's this one right here. What do we need to get rid of? Actually, we would love to have, well, from row 2 is pretty. From row 2, 0, 4, 3. From row 2, divide, go ahead, since column 1 is perfect, and divide row 2 by 4. Now, I know what you're thinking. Well, that's going to cause a messy fraction. I don't usually like to do that. But I've got a reason. Yeah, we'll get 3/4. But look at there. What does this mean? What do we have? We have, notice, we have y equals 3/4. Y, we have the y. See, guys, this means 0x plus 1y equals 3/4. This right here, this means 1x plus 1y equals 1. And this means 0x plus 1y equals 3/4. That just means plain straight up y equals 3/4. We have y is given away. The gig is up for y. We know who y is, right? There's no mystery. Y is 3/4. We could actually smoke out x right now, right? But I want to, you know what? Let's just keep on rolling. I want this one right here in row 1, column 2 to vanish. I want to get rid of the ones in the off diagonal. Of the ones in the that are not in the diagonal. This is going to turn out pretty. Okay, now what do we have? All zeros in the, well, what do we have? I'd like to do this. All zeros in row 3. We will have a solution. That's the more important thing I need to say. We have all zeros in row 3. We will have a solution. So I want to get rid of all the ones that are not in the diagonal. Namely, these two ones. Well, I want to keep these two ones, but I want to get rid of this one right here and also this one right here. So, well, now we want to keep the 3/4, obviously. Y equals 3/4, and we want to keep the two ones in the main diagonal. So what to do? What to do? Row 2. Well, row 1 minus row 2. But I want to put that in. No, don't mess with row 2. Don't change row 1 or row 2. I mean, sorry. Don't. We do want to change row 1. Don't change row 3 or row 2. We love our zeros, right? We cherish our zeros. So you don't want to mess with your zeros. You see this 0 here, guys? We cherish it. Don't revert it back. There's no going back. You see the 0 here, guys? You don't want to unzero it. You see the 0 here? We cherish it too. We don't want to go back. And likewise, this guy here. If you can get the 0 here, you cherish it if it's attainable at all. Which in this problem it was. You don't want to go back. So, and you see this one right here? We cherish it if you can get it. Well, if you can get it and have all 3 zeros here. It's the zeros, though, it's the 0 here, the 0 here, the 0 here, and, well, luckily here, the 0, we were lucky enough to get this 0 here. So, yeah, we value those zeros, even more than the ones. Okay, so we're going to do row 1 minus row 2 and put that into row 1. So we're going to get, so to make a long story short about this one, let me go back up to it. I got the wrong, well, no, it's absolutely correct, but I just forgot to state what the x and y value were. The x value was 1/4. The y value, I've left the problem now. So the x value was 1/4. The y value was 3/4. And if it would kindly take me back to the problem, that would be terrific. We know how that goes. So let's see, guys. But no, that's not even a file. Where's the file? Uh-oh. But here it is. Okay. Is this the file? Yeah, here's the file. Yep. Now here's the file. So we'll get back up there. So go on back up there, Microsoft. Microsoft can't mess up forever. So the final result, now y is not 1/4. That was a miscopy. Y is 3/4, obviously, right? So in ordered pair form, my final answer would be 1/4 would come first because that's the x coordinate, and 3/4 would come second because that's the y coordinate. Okay. Recordings are so hard to do, but we'll get there. I like doing them, but they're hard to do at the same time, you know? So, chipper. So, x equals 1/4. Notice anytime you have 1, 0, this 1, 0 row here is my x row. It won't let me do it. So, 1, 0, 1/4 means x equals 1/4. 0, 1, 3/4 means y equals 3/4. So, here's the ordered pair. And let me create a separate line for that. So, it's way down here. So we have x comma y ordered pair equals and 1/4 comma 3/4. Whew. Oh well. Thankfully, it took me forever to get back up here. So x equals 1/4, y equals 3/4. Now, guys, again, we got row 0, 0, 0, and that's why this is okay, right? If it wasn't for that, we'd be out of luck, right? Now, if we had 0, 0, 5, would be, or 0, 0, and somebody in row 3, column 3, if I had somebody other than 0 right here, I'd be out of luck. But thankfully, I have 0. If I had like 0, 0, 58, or anybody like that other than 0, I'd have no solution at all. But thankfully, I have 0, and I'm fine. My third equation was valid. It was just, it just didn't really add anything new. So, thank goodness. But anyway, there's that. Now, and another thing I wanted to say, this equation I kept botching up, and let's just go ahead and do it, because let me do it with matrix form, and I have the answer, but let me do it without botching anything up. So I have 2x plus 3y plus 4z is -3. And I have the second line here, and you can see what it is. Negative 1x minus 1y minus 5z equals 10. And I have 3x plus 1y minus 1z equals 6. Now, you take off the coefficients and you put them in a matrix, okay? Like this. Here's the 2, here's the 3, here's the 4, here's the -3. You put them in this row. It's just the corresponding matrix. It's structured out just like the equation. Now, that's as long as the equation is in the order like this. With x first, with y second, with z third, and with -3 coming last. Okay? And then we have, you always want it that way. Notice your x's are lined up column-wise, your y's are lined up in the same column, likewise for your z's lined up in the same column, and likewise for your solution column lined up in the same column. So look, here's 2, -1, 3, if you look at it from the column point of view. And from the column point of view, here's 3, -1, +1, like this. And from the column point of view, for column 3, here's +4, -5, -1. And then here's your solution column. Okay? Now, guys, what we want to do, if you're on, we considered the variable column without the solution column. Well, we're going to need the solution column, but let's ignore it just for a minute, okay? Now, look at the main diagonal. The 2 and the -1 here, and this -1 here. We want them, at the end of the day, we're going to try to make it, we want to end up with one here, and with positive one here. So positive one, positive one, positive one. But everywhere else, we want zeros, except for the solution column. Now, the solution column's different. You know, we could get whatever there, who knows what. But we're going to find out what. But the solution column is who only knows. But now, everywhere else in this 3 by 3, we want zeros. Like we want this 3 to be 0 at the end of the day, or to become 0, rather. And we want the 4 to become 0 at the end of the day. If you're not on the main diagonal, we want you to become 0 when it's all said and done. But if you are on the main diagonal, we want you to become positive 1 when it's all said and done. Now, the zeros are the most important thing. We get them first. We pivot everything around those zeros because they are what makes the machine run, okay? So what we're going to do is we're going to take this matrix and start running. Now, first off, it's always nice to have, this is not totally something you have to do, but it's nice. We're going to row swap row 1 and row 2. It's nice to have either a positive or neg 1 at the top left, is what I'm referring to. So we got neg 1, neg 5, 10. I just swapped row 1 and row 2. And I put row 2 where row 1 used to be. Okay, and you know, vice versa. I didn't mess with row 3 yet. Now the next thing we're going to do, pay attention to column 1, okay? Pay attention to column 1. So in column 1, what I'm going to do is I need the least common multiple for column 1. I need the least common multiple of, well, and we ignore negatives. I need the least common multiple of 1. Well, just when we're doing the least common multiple, we don't know where negatives per se, but just when we're doing the LCM. So I need the least common multiple of 1, 2, and 3. But 1 doesn't really count, so we can kind of ignore it. The least common multiple of 2 and 3 is 6. So we need to turn everybody, we need column 1 to be filled with either 6s or neg 6s, right? With neg 6 and or 6. It doesn't matter if it's neg 6 or pos 6, but we need column 1 to be filled with 6s of either pos or neg. So what I'm going to do is I'm going to multiply row 1 by 6, because I need to turn neg 1 into 6, I'm going to have to multiply it by 6. But if you multiply that guy by 6, you're going to have to multiply all its buddies in row 1 by 6. So you're going to get neg 6, neg 30, and 60. Okay, now let's look at row 2. Now let's multiply everybody in row 2 by 3. You got to multiply 2 by 3 to get 6, right? So you're going to have to multiply all of 2's buddies. Your buddies are in the same row. So you multiply all of the buddies by 3 because you had to multiply this guy right here by 3. So times 3, of course, we get the 6 that we wanted. Now 3 times 3 is 9. 4 times 3 is 12. Neg 3 times 3 is neg 9. So there's that. Now for row 3, we have to multiply it by 2 to get the 6. So we have to multiply all its buddies in the same row by 2. So we get 6, 2, neg 2, and 12. Now here's the deal. Now here's the gig and here's the deal. We add, remember what I told you. You look at the main 3 by 3, the diagonal that goes with the x, y's, and z's without the solution column. Okay? Now, I want this neg 6 to laser blast this pos 6 and this pos 6 here. So I've got to add row 1 to row 2, and then separately, I've got to add row 1 to row 3. They're separate processes. Okay? And that's what I'm talking about. When I'm talking about that, that's what I'm talking about right here. Okay? And it'd be nice if I scooted that on down the highway there. Uh-oh, I don't want to scoot it down that good. And then, so going to the next page, Word has strange ways. So row 1 plus row 2, if we add those, I need these in my same view. Thanks a lot, Word. Okay, Word, how I hate thee. Okay, go back. Okay, Now, if I add row, okay, so it's like Word wants me to hate it. Now, I add row 1 to row 2, and I get, well, -6 and +6 give you a 0. -6 and 9, if you add, now here's where you don't have a choice. You add row 1 and row 2, okay? Now, you're like, well, Jason, could I have done my own negatives? Could I have, like, maybe multiplied row 2 by neg? Yeah, you have choices there, but here's where you don't have a choice. You have to do your put command on row 2, because if you don't, you'll get your zeros in a bad place. Well, I guess you could always do a row swap, but guys, that gets mighty aggravating after a while, having to do row swaps, and you're going to get really confused. Just do your put command right the first time, and save yourself having to do a lot of row swaps, okay? So -6 plus 6 is 0. That's good. And notice that's nice. But now you've got to do the collateral damage. So you got to do -6 plus this 9 is this 3. -30 plus this 12 is this -18. Or +60 plus this -9 is +51. And we do the put call on row 2. That just saves us from having to do like row swaps and later. And it may actually, to be honest with you, yeah, you don't want to put that in row 1. Don't do that. Okay, now row 1 plus row 3. Now you don't have a choice. You need to do your put call in row 3. Trust me, you don't really have a choice there, or at least yeah, I wouldn't want to play with that fire. So now -6 plus 6 is 0. That was the whole point. Remember, guys, off diagonal, you want to have a 0 for this 3x3. Yeah, there we go. Okay. Now, -6 plus 2 is -4. -30 plus -2 is -32. And then now the collateral damage, you still got to add the solution column 2. He's no exception. 60 plus 12 is 72. You have to add the solution column as well. Okay, now we've cleaned house in we've pretty much cleaned with the exception of dividing by -6 or 6 or whatever. We've pretty much cleaned column 1, right? Except for dividing unitals, which is pretty easy to do. We've cleaned column 1. Yeah. Okay, that's good. Now we need to get rid of the off diagonals. So I need to get rid of the term that's in row 1, column 2. And it would have been nicer if I would use parentheses to note that, but it's a little late now. And likewise, row 3, column 2. So I need to get rid of the terms. Well, what am I talking about? Row 1, column 2. I need to get rid of, let's look at column 2. I want the 3 to survive, or at least I don't want it to be, it would be bad for that to be 0. But I do want -6 to be 0, and I do want, or to become 0 rather. And I want the -4 term to eventually become 0. Obviously they're not 0 yet. Okay, so what about it? I do row 2. Now I'm going to go ahead, let's clean house. We need to do some house cleaning. There's a lot of dust in this house. So you could divide by -6. I got lazy. I just divided by +6 here. If you want to divide by -6, that's totally fine. I left it -1, whatever. In a way, I kind of paid the price, though. I made an error a while back. But if because I got clumsy, not because of the math, just because of my own personal clumsiness. But yeah, in a way, dividing by -6 may have been a better idea, but it's too late now. So I did row 1 divided by 6. I put it in row 1. So that's -1, -1, -5, +10. If you divide by -6, you're just going to change the tags on all these. And but anyway, too late. For me, anyway. Now divide by 3. Here you get 0, 1, -6, 17. Now we can divide by, I did -4. You could just do +4. You can vary, right, with negatives. But anyway, I chose -4. Divide by -4 on row 3. I'm just cleaning house. I want to have all ones here. It's just pretty. And I have 0, +1, -8, -18. Now these columns here are kind of rough. But this column 2 is pretty. Column 1's real pretty. And if I would have, did my diligence on that neg 6, I would already have a total pretty. Anyway, and let's go on. But I'm okay. Now, so we have this guy. I just did copy and paste here. Not much to say. Copy and paste. So let's go on down here. I just did copy and paste again. Was that really necessary? No, not really. That was just me kind of doing I was just catching my breath. So you want me to get rid of that because I was almost dilly-dally too long. Now, guys, what I do next is I do row 2 plus row 1. Now, and I'm going to put that in row 1. You must put that in row 1. You don't have a choice. Because I want this positive 1 to kill this neg 1 and put a 0 there. And then, now here's the deal. I want to do 1 minus 1 here. These are the same sign tag. So I got to do 1 minus 1. And I want this 0 to go here in row 3, column 2. I want this guy right here to be this guy right here to be 0. So you could do row 2 minus row 3. You could do row 3 minus row 2 like I did. But the point is, you have a choice there. What you don't have a choice on, you must put it in row 3. Period. Whatever you do, you'll either get what I got or you'll get the negation of what I got. Doesn't matter. But you can't get anything, you can't be in the wrong row. So, but now, so if you do all your stuff, now row 2 plus row 1, 0 plus neg 1, no change. Put it in row 1. No change though. Now 1 plus neg 1 is 0. Here it is. Neg 6 plus neg 5 is neg 11. Here it is. I'm sorry it went to the next page on me. And then 17 and 10 is 27. Here it is down here on the next page. Gotta love Microsoft. Now, don't mess with row 2. Don't touch it. Now row 3. Well, use it to do your stuff, but don't touch it. Now row 3. Now we need to subtract. And I did row 3 minus row 2. So 0 minus 0, no change. Now 1 minus 1 is 0, but I have to put that in row 3. So, and here it is. So we have 0, 0. That's nice. Now 8 minus a neg, that's 8 plus 6, that's 14. Now be careful. Neg 18 minus 17, that makes you even further in the negative. That makes you neg 35. Okay. Hey, look at there, look at there, look at there. 0, 0, 14. That's nice. Now divide row 3 by 14. That's just going to give you 0, 0, 1, and a negative somebody. But that somebody is neg 35 over 14, and that somebody reduces correctly to neg 5 halves. And all these answers are correct. I've checked them a billion times now. I went through the ringer on this today. I mean the ringer. I got the wrong answer about 100 times. I ought to know. Now, here's the deal. Now, I've still, what did I do now? I still got, okay. Oh, okay. Now, what do I do next? Okay. Catch our breath. So we've got this. Now, there's good news and there's news. What do we need to do? Well, can we catch our breath? Let's go ahead. Why on earth did what possessed me to, I went ahead, I multiplied row 2 by 2. What possessed me to do that? I multiplied row 1 and row 2 by 2. And yeah, that's the correct scaling. I doubled all the terms in row 1. I doubled all the terms in row 2. Nothing wrong with doing that. What possessed me to do it? I at least need to denote that if I do it. Well, so that's okay. If I want to do that, I guess that's my business. But I at least need to note that. So also do 2. Why did I do that? That's unfruitful. That's correct, but that's not fruitful. Let's just not do that, shall we? That's not wrong. It's just not fruitful. I see no point at this time. Okay, I see why I did it, but it's premature. It's not the time. Not the time. Come on now. Go back to -6. Go back to 17. Okay, yeah, that was way premature. So let's just go back now, and then the next page is not down there; it's over here. So now, what's the next logical step? Well, this was just me catching my breath. There's really no point in me writing the same guy twice. Really? No, let me do it. It would be nice to have this guy up here where I can see him. So I'll write him twice. No loss. So let me do... Well, what about it? I need to do... Well, what I need to do is... that -5 halves... I copied this guy down way too many times, though. So, yeah, way too many times. I don't care to copy him down again, but I don't want to copy him down like 100 zillion times. So, no, he doesn't need to be copied down that many times. I already have him here again. So now, what do we have? So what I do, that -5 halves, so we know that z is -5 halves. Hey guys, look here. So we know z. What does this tell us here? We have 0, 0, 1, -5 halves. If you ever have 0, 0, 1 and somebody, that means that somebody is z and he equals this guy in the solution column. Hey, that's z equals -5 halves. If I didn't say that a minute ago, I should have. We have our z variable. One of our guys has been smoked out. We've sort of apprehended one of our suspects here. Z is -5 halves. Okay. Now, we're happy with the bottom row. We never, ever again want to... We can't do a put call ever again in the bottom row. We can use it, but times. A billion times if we want to. We just can't do any more put calls down there. We can't place anybody down there, in other words. So what about... Okay, so here we go. Here's our magic guy. Now, I like not to have fractions if I can help it. It's not that I can't have fractions. It's just they make the math so hard. So I'm going to multiply the row 3 by 2 and place it into row 3. So I'm going to do this guy right here. And I'm going to, that'll turn 0, 0, 1, -5 halves into 0, 0, 2, -5. Hey, no more fractions for the time being, right? Now, okay, now that the fractions are temporarily gone, look at column 3. Column 1 is beautiful. Column 2 is beautiful. Column 3 needs some dusting, right? So 11 is kind of hard-headed. Let's try 2 and -6. We could do 11, but I don't want to. Let's do 2 and -6. All we got to do is multiply 2 by 3, and we got it made. We'd have +6 underneath -6, and we could use, if we multiply row 3 by 3, we would have 0, 0, 6, -15. But it's the 6 that I want, because I could use that 6 to laser blast that -6 to 0. Remember, -6 is not on my diagonal, so I want him to 0 off to 0. So look, let's see. So now guys, the least common multiple of 6 and 2 is pretty obvious. It's 6. So we don't want to mess with row 2 at all. We just want to mess with row 3. So just do 3 times row 3, the old row 3, and put it in the new row 3. And that's all I'm saying here. This will position row 3 so that we can wipe out the -6 in row 2. And that's what I said here verbally. So we do that, and I'm going to let row 1 just sort of hang out for the time being. So we get 1, 0, 11, -27. I get 0, 1, -6, 17. And I get, I didn't mess with row 2 or row 1, but now row 3, I multiplied it by 3 in order to get the motive, and it speaks to motive. I wanted this 6 right here, so I get 0, 6, -15. Look at there. Guess what I'm going to do, guys? Now, you got to do your put call in row 2. Remember, I said no more put calls in row 3. So row 2 plus row 3, and I'm going to put that into row 2, because remember, that's a put call right here. This arrow is your put call. So I'm going to put that into row 2. Okay, well, Look at there. 0 plus 0, no change. 0 plus 1, no change. Now, 6 plus neg 6, 0. And I call that into row 2. Now, neg 15 plus 17 positive is 2 positive. Call row 2. Look how pretty that is. And look at there. That's 0, 1, 0, 2. That means y equals 2. We smoked out y. Y equals positive 2. That's nice. But now if you divide row 3 by 6, which is the same thing as, so row 3 divided by 6, 1/6 row 3 in other words, and you put that in the new row 3, the reason I'm doing that's just to go back to 1 again, right? We're cleaning house again, right? We're house cleaning. We've done our do. After you do your annihilating, you want to go back and do some house cleaning every time. So you go back to neg 5 halves. So, well, we've got our y equals 2, so let's gather our flock. We've got z equals neg 5 halves, and y equals, y equals 2. This is okay. We're not doing ordered pair yet, so I can kind of get away with this. Okay. But now here, so we know who z and y are. They're not going anywhere. Now we just need to get x. Okay, so again, let me go ahead and blast out that neg 5 halves again. Yeah, this is the answer, but let's not peek. Okay, that's the answer. Okay, let's not peek. I'm gonna multiply by 2 again. Actually, I'm gonna do neg 2 this time. I'm gonna multiply row 3 by neg 2, and I'm gonna get Microsoft. I'm gonna get angry at Microsoft, and I'm gonna multiply row 3 by neg 2, and I'm gonna get 0, 0, neg 2, pos 5, just changing the signs. Now the least now notice here, guys, I need to get rid of. I don't want to get rid of the neg 2, or at least I don't want to make it 0. Is what I'm saying. I want the 11 to turn to become 0 later, or actually real soon now. I want to blast 11 down to 0, nuke it out. So I want to multiply the least common multiple of 2 and 11. They don't have anything in common, so it'd be 22. 2 times 11. So I say that as much here. So I multiply row 1 by 2 and row 3 by 11. So 11 row 3, put that in the new row 3. Now, I know what you're saying, Jason. You're doing a put call. But this is really a fake. This isn't a true put call. This is just a multiple call, right? So, yeah, you can't do you can only do trivial put calls. So I'm doing, this is a fake put call, right? So you can't do any additive put calls in row 3. So that's what I was really saying. You can do multiple calls, you can do trivial calls in row 3, but we can't do any non-trivial put calls. So I guess I sort of did do one here, but it was the trivial one, and that doesn't really count. And then now 2 row 1, call row 1 again, but this putting a multiple back in that same row, that doesn't really count as a put call. That's kind of what we'll call a trivial call. To me, a put call is when you add something, an additive put. And when you add, this is a put call when you have a plus sign. If you just have a multiple, that's a trivial call. I should have pointed that. And they don't use the word put call in math. That's just something I kind of came up with. My colleagues would probably be like, where's he getting this lingo? But you can't do any additive put calls in row 3 because the reason we don't want to do any additive put calls is because I don't want to mess with these zeros here in row 3. It's the same reason, and also I don't want to mess with row 2 now, or at least except for the trivial call, right? I don't want to do any additive calls in row 2. You can do the multiplicative trivial calls just fine, but I don't want to do any non-trivial calls. Okay, now, so I do 11 row 3, put it into row 3. I do 2 row 1, or the trivial put here, and I get this. Why did I do that? To get 22 here and neg 22 here. I want the cancellation action of the 22s. Action of the positive 22 and the neg 22. That's why. That's why I'm doing this. So, now the non-trivial put call is going to be row 1. any non-trivial put call that I do will be put in row 1, right? So here we go, guys. Here's a true put call, a non-trivial one. Row 1 plus row 3, put call row 1. Now we do that to cancel the 22 in row 1. Now we don't dare do that in row 3, right? So, and we want to do that, we do that to cancel the 22 in row 1, column 3 in particular, right? This guy right here. This old 22 that we used to have right here, that pos 22. In particular, it's the pos 22 that we want to zero out. It's the pos 22 in row 1, C3 that we want to wipe away, right? And here we did. We wiped it away. It used to be here. Now notice the neg 22 is still here. But guys, okay, that's good. But remember, we won't, at the end of the day, that neg 22, it's not going to be 0, but we do want to bring it back to 1, positive 1, right? It's on the main diagonal in the 3 by 3. So we just divide row 3 by neg 22. So to say the same thing, multiply it by neg 1 over 22 and put it in the new row 3. But that's just a trivial call. That's not a true put call. And now we can't do any more put calls. It's over. All these rows are in the pretty form. No more non-trivial calls. We can do trivials all we want, but no more non-trivials. So 1/2 row 1, trivial row 1, neg 1 over 22 row 3. We just want to adjust everybody back to 1 here, right? And that's what we do. Look here. This is the X row, the top row, the middle row is the Y row, the last row is the Z row. I mean the row that goes with Z variable. So we get X equals positive half, Y equals positive 2, Z equals negative 5 over 2. Now guys, remember when you write the ordered triplet, X has to come first, Y has to come in the middle, Z has to come last. Now if you're ever in, that's that for this problem. Now guys, if you ever have 4 variables, X, Y, Z, W, X first, Y second, Z third, W fourth. Now, we don't have a W in this problem, but anyway. That's how it goes. And I didn't really do the best job with this problem later on. I got real clumsy and made a bunch of mistakes, but I wanted to do it right without bumbling around. And you see this row here? What's this row really saying? It's saying 1x plus 0y plus 0z equals 1/2. But 0y is gone. 0z is gone. 1x is just x itself. X is 1/2. And this is the second row, on the other hand. 0x, which is gone. It's gone. 1 plus 1y, but that's just y. And plus 0z, but that's gone. So we're just left with y equals 2. Remember, guys, this column right here is the solution column. This is the solution column. 1/2 is my x. Positive 2 is my y. Negative 5/2 is my z. Pos half x. Pos 2 y. Neg 5/2 is z. So here it is. And now, what are we philosophically? You know what we're saying? That the original 3 planes that we had a long time ago, the original 3 equations that we had 15 minutes ago or whatever, they cross at only one point. They cross at this point right here, 1/2 to neg 5/2. They cross where x is 1/2, where y is 2, and where z is neg 5/2. That's just one point. That's just a single point. They don't cross in. Well, I need to put it this way. There's only one point where all 3 planes cross. Now, there may be other points where any 2 of them cross. There may be other points where like just 2 of them cross. But there's only one point where all 3 of the planes cross. At the same point. And that's this point right here. That's visually, that's what that means. And so that's visually rich. These planes, there's only one point where they all 3 collide at the same place, and that's this point right here. Thank you, guys. what if we have but if you want to solve it the way we did 2D systems, you can. Like you could multiply row 3 by 3 and line up your x's. Well, actually, no. Just add row 1 to row 2. It's really the same thing in disguise. Like you would add row 1 to row 2. And what would happen to you, let's say you want to put it in row 2, that you want to add row 1 to row 2 to kill your y's, right? Your y's would kill each other. You can see that they're going to kill each other right away. And now 3x, you're going to put it in row 2. Row 1 plus row 2. And you're going to put it into row 2. It's just the same thing, guys. It's just you're not doing a matrix. And so what's going to happen is 3x plus neg 1x is 2x. The y's kill each other. But if anytime you do that, it's a good idea. The y's are dead, but I would keep a 0y here, because if you don't, you're not going to stay lined up. And then now you got your precious 0y, and then negative 1 plus neg 5 is neg 6. 6 plus 10 is 16. And we know what the answers are going to look like. So next do, what do we got here? Okay. Hey, we got the 2x's, so do row 1 minus row 2, and you're going to want to put that in row 2 because it's off diagonal, right? So, but to kill that 2x on the row 2 there. Well, I kind of want to move down the page. But you can solve this the equation way, and what's going to happen to you is you put this in row 2, so you're going to get, now you don't want 0, well, wait, yikes. I got, you know what, I put 0y in a bad place, didn't I? I sure did. That was on the diagonal, wasn't it? Oh boy, if you put a 0 on the main diagonal, you're going to need to do roll swap. That's okay, guys. If you do that at the beginning, it's okay. Just do roll swap. So roll swap, row, let's just say row 1 and row 2. It would have saved me time if I would have kind of maybe, I should have done a different put command. That's okay. So I've got, so what I'm going to do is just, well, I can't do this guy yet. That's postponed. So what I'm going to have to do is I'm going to have to do, I'm going to have to roll swap. Now, so this guy, I'm going to hit Control C. Anytime you're using Word, guys, please do Control C and Control V. Don't be like me. I've learned what I learned the hard way on this one. Now this needs to go up here. So do that. Space down. Now, because if you're on the main diagonal, you actually don't want to be 0. Okay. Now, let's see. Now I want to subtract the rows, but I want my 0. Now my 0's in a good place. So if I subtract my rows, I want to put on row 2. So row 1 minus row 2, and I want to place it in row 2. So if I do that, you think like you think back when we did the matrices. You have the same line of thinking. Now, so 2x minus 2x is 0, but you want to stay, 0x is 0, I know, so is 0y. But you need to stay lined up. Or if you don't, you're going to get confused. I know I would. Now, 0 minus 3 is neg 3y. That's okay. Now, neg 6 minus 4, now that's all the more negative. That's neg 10z. 16 minus a neg 3 is actually positive 19 on the solution column there. Okay, we got our off diagonal 0, so we're getting there. Really, I ought to be strategic and stay down the column. That's what I'm supposed to be doing, is stay down the column, but that's okay. So I've got my 0 here. It's always nice, I guess. You can, it's good to do column by column like I did with matrices, but the only reason it didn't seem good was my arithmetic errors. But it's actually the best way to go, is column by column. I kind of, well, put the It's okay. It's still okay to do it this way. Now, 3x and 2x, that's kind of unfriendly. Um, you know what looks a lot friendlier is this y guy here. Well, not the 0, but the 1y and the neg 3y. Let's multiply. Let's just go ahead. Well, 1 and neg 3 beg to be annihilated. Let's just go ahead and multiply row 3. I'd like to make this 3y so it could hit that neg 3y. Well, no, actually, I would like to make this 3y so the neg 3y could hit it and annihilate it. I want this neg 3y. I don't want to zero out this neg 3y. I want this neg 3y to zero out this guy. So I'd like to get 0 here. So I'd have 0, a non-zero, and a 0. So with that being said, I'm going to do 3 row 3, and I'm going to add it to row 2, but I can't put it in row 2. I got to put it in row 3 because I don't want to get a 0 in the dead middle. I don't want a 0 in my main diagonal in my variable matrix, or what would be my variable matrix. Okay. So with that being said, well, how about before, that's where we're going, but how about I just do 3 row 3, because that's a lot to keep up with. I've been trying to avoid doing that because it confuses students, and it gives, I find it a lot to keep up with. So let's just do 3 row 3, and that's going to be 9x, 3y, 3z, and 18. So and I put that in row 3. I need to put where I put it. That was in row 3. So now Control C, and then Control V, and now instead of doing 3, I can just straight up do what my new row 3 straight up plus row 2, and now I'm going to want to put that in row 3. Row 3 is really getting picked on, so because I want this 3y off diagonal to go away. Well, now, so it is, and so it be. So 0 and 9 is 9. Neg 3, 3, that's why I did this, was to make this go away. Neg 10, I'm adding because they're opposite sign. That's a beauty. Now, neg 10 and neg 3 is neg 13. 19 and 18 is 37. So I have that. Now, here's the dig. Well, I've taken care of column 2. It'd be nice if I took care of column. I guess I need to take care of column 1, though. I'm still a long way from home. 2 and 9 don't jive. So let me do 9 times. I may as well just, I guess, bite the bullet. I don't see anything that all that nice. The column 2 is taken care of. I may as well just do 9 times 2 and 2 times 9. So if I do 9 row 1, 9 needs to hit this 2, 2 needs to hit this 9. 9 row 1 stored into row 1, and 2 row 3 stored into row 3. And here's Johnny. Control C, and then Control V. Well, so multiply by 9, that's 18. 0 stays. 9 times 6 is 54. 9 times 16 is 144. I know that by whatever perfect square thingy. Now multiply by 2's down here. That's 18x times 2. That's minus 26z times 2. That's 74. Yucky, yucky. Now, the off diagonal is who needs to die. Row 1 as far as min 0 is concerned, just mathematically speaking. That's all. Row 1 minus row 3, and I need to put that in row 3. So, well, let me copy and paste this guy. At least Word is friendly sometimes. So Control V. 18 minus 18. I got to subtract this time. Is gone. 0x, and then this is still gone. Oh boy. Neg 54 plus 26 is, that's going to be neg 18. I got to be careful there. That's kind of scary. Yeah, that's a little frightening. Neg 54 plus 26. Guys, no. Some don't feel good. That's 28, isn't it? I don't know if that feels good at all. Yeah, 35 over 28. 35 over 28. And then I don't know if it feels good. 35 over 20 now, and 144. And then that's going to be, if I subtract these, that's 70. Yeah, that was hard. Okay, so I get 70. Now I got to get -5 halves here. I do. I do. Yeah. And if I divide, I get my precious -5 halves. And if I divide row 3 by -28, if I do -1/28 row 3, put that into my new row 3, I will get my precious 5 halves for Z. Control C, Control V, and I'll have to scoot down there. Oh, be good to me. Be nice to me. Be nice. Please be nice. Okay, so that's plus Z. That's going to be now. That's -70 over 28. Technically speaking, but now, guys, thankfully, 14 goes into 28 twice. 14 does go into 75 times. There we go. Okay, so we came out on top there. So in other words, to say the same thing, Z is equal to -5 halves. Okay, now, we've gotten Z. Z is behaved. So, and there's an understood 1 in front of the Z here. Okay, now, what do we... Now we can use the bottom guy as the bottom row 3 as a laser to sort of laser out some stuff. Now, if I multiply row 3 by 10, well, no, what? Well, let's see. I'll kind of have to. Let me just go ahead and multiply row 3 by 2 to get. If I multiply row 3 by 10, we can bear it. Let's see. If I do. If I do 2 times row 3 and put it into row 3, I'll get -5 instead of -5 halves. Okay. But then I'm doing a lot of surgery on row 3 here. And then that -5, I've got 1Z, but I'd like -10Z. Well, actually, I'd like positive 10Z. That'd be polar opposite. So now if I do 10 times that row 3 and put it into row 3, well, come on, be good. What will I have? I'll have 10Z, -50. Holy wow. So, well, now if I add row 2, now you got to cancel the off diagonal. We don't want this 10Z to be 0. We want the -10Z here to be 0 because it's off diagonal. Okie dokie. So I do row 2 plus row 3, but I got to put that into row 2. Have mercy. Okay, so, well, Control C, Control V. Let me get a space here. So with that being said, these can, I get what I want with this, my plus 0Z. It wouldn't really matter if I said minus 0Z. 0 is just 0. But anyway, I add the 2, stay put, stays put. This cancels, that's why we did it. Now, -50 and 19. What about it? Uh-oh. I don't know if do I like this or not. -50 and 19. Uh-oh. Uh-oh. That's going to give me... I wish I'd get... Uh-oh. That's not quite right. I'm getting the wrong thing. I'm not going to get the right thing. I don't, yeah, I'm going to be off. I need to get y equals 2 here. Neg 50 and 19. Uh, that'll give me negative, uh, that'll give me what, neg 31? But that's not right. So, uh-oh, what went wrong? Where's the trouble in paradise this time? Um, okay, where's the trouble in paradise? It's on my second row. Uh, so is 19? What's so wrong with 19? Um, so I traded places, and I did row 1 minus row 2. Well, there shouldn't be anything wrong with 19 that I see. Yeah, I did control paste here, in fact. Let's see. I copied the problem down right. 2x plus 0y. Is this even the same problem I was doing before? Wait a minute. Actually, there may not be. Guys, is this even the same problem I was doing before? Yeah, it was. If I add row 1 to row 2, I get 2, yeah, and I get my 0, I get my neg 6, and I get my 16. So yeah, and I put it in row 2, which probably wasn't the best idea at the time. It was just inefficient, but it was okay. And I copied everything back down correctly. Okay, yeah, it's the same problem. It is. Okay, it's telling me it's not locking my 19, and I'm trying to find out why. Let's see, 0. If I subtract, I get, okay, 2x minus 2x is 0. That's neg. That's, and when I subtract, I got to put it down below. Yeah, I don't see a problem because you minus a neg 3, you're going to get 19. And again, my motives were obvious. I was just wanting to get my non-diagonals. It's telling me I just made a simple arithmetic mistake, is what it's telling me. Now, 3 row 3, now put that into row 3. Yeah, I didn't forget anything. Now, row 3 plus row 2, and I put that into row 3. Okay, yeah, that'll cancel. That's an egg 13. That is 37. Okay, right. I don't see any beef. Now, if I do 9 row 1, and I put that into row 1, 9 times 16, that is 144. Right, and then I do 2 row 3. Yeah, I don't see a beef yet. Okay. Well, now then I do row 1 minus row 3, and I put it into row 3. Huh. Well, I'll be. Now, this couldn't be all that bad. I got the right z value. I'm getting the right z value. Oh, z's neg 5 halves here. When I scaled back, I forgot my 5 halves there. Okay. Yeah, that's neg 5 halves. Okay. I did. Okay, when I scaled back, this is. Okay. This is neg 5 halves. So if I multiply by 2, that needs to be 2z there. Oops. Okay. At least it was way later that I made the mistake. Okay. Okay. Okay, that's 2z in neg 5. Okay. So now. And then now if I do 10 times row 3, oh, that's 20z. And that's still neg 50. Oh, okay. And if I do row 2 plus row 3, oh. But now the 10s don't match. I don't want to do, well, now the whole point was for me to kill this neg 10. But now to do that, I would actually need, I don't really want to do 10 anymore. I want to do 5. I just need to do 5. I want this 2z to be 10z to kill this neg 10z now. So I just need to do a humble 5. Okay, and that's neg 25. And no, this is still 10z. Okay, 2 times, yeah, multiply this row by 5. 0, 0, 10z, neg 25. Okay, I was just trying to find my arithmetic mistake. I made another one. Okay, so we got that. It was just, I forgot, when I did my 2z equals 5, I forgot to turn my z into 2z here. Well, no, actually, yeah, okay. Yeah, okay. So we got that. Now, if we add, let's combine these. Now, okay, like our process has been right all along. So 10z and neg 10z make 0z. Now neg 25 and 19, thank goodness. Bye-bye neg 50, good riddance. Neg 25 and 19 is going to be neg 6. That is a whole lot better. And that's going to give me my beloved y equals positive 2. Looking good, looking good, looking good. Okay, so we can clean house now. We can go in and clean house. And I'm just going to, might as well just go over here. And just reduce all the rows, like just whatever, like 1/10, row 3 goes to row 3. And then now you could divide by 3. That's the same thing as neg third, row 2, and that goes into row 2. And then now row 1 we've not got cleaned up yet. We've still got an off diagonal neg 54. Whew. So let's just go on in and do what we need to do. Let's get that. Now neg 25 over 10, that reduces to what we think it ought to. Neg 5 halves. And then neg 1/3, that's just dividing by 3. That's plus y. Plus sign. And then this is 2. And now, now let's just go ahead and divide. Let's do what we can with row 1. 18, I can divide by 2 at least. What about 6? Let's divide by 6. Yeah, I think that's where we came from, in fact, right? By the sort of circular, going back full circle. So 3x, no, wait. Yeah. And divide by 6, that's 9z. Could I do one better? I could divide by 18, couldn't I? 18 times, well, 18. Yeah. 18. Well, 18 to go into 72. 18 times 8. Well, 18 times what? 72. 18 times, well, let's go back. 18 times, well, no. Well, 18, no. Let's just, let's not get ahead of ourselves. If I divide by 9, I get 2. If I divide by 9, I get 6. And if I divide, it's 9. If I divide by 9, I get 16. But yeah, I could have divided by 18 because I can, yeah. If I divide by another 2, I get 1, I get 3, and I get 8. Yeah, I guess I could have. 18 times 8 is 144. Okay, yeah, it is. It's 18 times 8. Okay. So there's that. All right. So we cleaned house. So we don't 1/6. We could have done a whole lot better. 1/18. Divide row 1 by 18 would have done the trick. 18 times 8 is 144. Okay, but now one last call. I want to do 2 times row 3 to make it to get rid of the 5 halves one last time. We know who Z is, so he's not going anywhere. And so we're in good shape. We've got the correct Y and the correct Z. We're in fine shape, actually. So make that 2Z, don't forget, like I did last time, and make this neg 5. Cross all your Q's and your P's. Okay, so we got 2 and 3. Now the LCM of 2 and 3 is 6. So we'll need to do like we'll need to multiply this -3 that we want to go away by 2. And we'll need to multiply the guy we're using to furnish the fact, this 2 here, by the 3. So we do 2 times row 1, put that in row 1, and 3 times row 3, and we'll put that into row 3, and we will get, well, we will get, what will we get? What will we get? I may as well go to the next page. Let's do it. 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 So 2 times row 1. Well, now, you're going to have to put up with 2x. That's just collateral damage. But now here and then here, collateral damages. And then multiply by 3 here. And here's collateral damage. But that 2x shouldn't really cause any real harm or foul. That's just a very mild nuisance. So now do, well, row 1 plus row 3. And I hope you know to put it in row 1, because it's the off diagonal we want to go away. So let's do it. For goodness sakes, you don't want to put it in row 3. Control C, Control V. Well, I don't want to get too huffy. I've made my own mistakes, but that is an insight I want you to have. I want you to see the big picture. So add row 1 to row 3. 0x and 2x, no change. 0y, 0y, no change. Now, 6 and -6 is 0. So put that there. Now, Now, -30 and 6. Okay. Okay. What am I going to do here? I didn't want to get, okay. Now -30 and 16 is that's -14. Now, I didn't want it to be that nice. That's a little too nice. Yeah, that may be a little bit too friendly. Let's see. 6z is -30. So hold on. Well, what did I do? That's a little bit too friendly. Hold on. So 2z is -5. So multiply that by 3. Wait, I multiply by 3. No, it's -5. I multiply 2 by 3. I multiply 5 by 3. You get -15. It's not -30. It's -15. Because it's 2 times 3 is 6. So you multiply 5 by 3. It's not -30. It's -15. Okay. And I multiply by 2. That's right. Okay. Sorry, guys. So this -30 should be -15. Now, I thought that was a little too friendly. That's better. Okay, so -15 plus 16. Now these will cancel each other, and I'll get my plus 0z. Now -15 and 16 is 1. And I get z equals, yeah, that's 1. And I'll get z equals a half, and that's what I had before. Okay. I mean, sorry, not z. I'll get x equals a half. X equals a half, not z. Sorry. So x is positive half, y is positive 2, and z is going to be -5 halves. And let me see. So x pos half, y pos 2, z is -5 halves. And from a long time ago, does that sound like it jives? From a long, long time ago. And what did I get moons ago? Let's see. Yeah. Well, yeah. Half to -5 halves. Yep. That's it. That's it. That's it. So let's just go back down and finish it off. So easy to make a mistake. Every bone in my body wanted to multiply by the whole Monty and get 30 instead of 50, or -30 instead of -15 or whatever. So let's just go back down and finish it. When I'm typing, it's just hard for me to hold concentration when I'm writing. But, I can't convey anything to you guys typing on paper. But, no, that's just no excuse. Let's just go back down and finish this, shall we? Let's get on down the highway here. Let's go, let's go, let's go. No, that's not -30. That's -15. Yeah, come on now. Okay, so -15 and 16 is +1. So there it is. Okay, guys. Now let's just and now do row 1, half row 1, put it into row 1, and do 1/6, row 3, put it into row 3, and let's do it. And I'll get my echeloned out equation. I'll get the real McCoy. I'll get 1x. It'll be echeloned out. And there'll be notice you have the understood 1 there and there. And of course, now, okay, and if I divide by 6, that's now 1. And now neg 15 over 6 reduces, if you reduce it, you get neg 5 halves. Okay. Now, some, of course, a lot of professors, they won't write the 1s. They'll just leave them be. But look at there, look at there, look at there. There it is. But this is the same thing as just saying x equals a half, y equals 2, and z equals neg 5 halves. Because 0y is just gone. 0z is just gone. You're just adding 0 to x, And likewise for the y here, you're not really contributing anything to the y equals 2. It's just that, and ditto analogously for the z here. Wow. Okay, guys, that's what a rush, right? What a rush. What a rush. That's something else. And if you want to put it in order triple mode, you'll need to put the half first, the 2 next, and the last thing you'll put will be the negative 5 halves. Now, some authors will go decimal mode. I'm not really a big decimal mode fan. I like fractions, but oh well. But you got to put them in XYZ order. It's an order triple. Now, these are what's going on here is we have what I was trying to get the graph of and couldn't get it. We have 3 planes that intersect at this single point, a point denoted by the order triple, that I can't get the graph of, by the order triple 1/2, comma 2, comma negative 5 halves. Desmos and all them, they really let me down today. They apparently want my money. But like I would have let me just type in a generic graph. Of course I want to leave. You guys let me down. A graph that meets at 3 points. Wait, 3 graphs that meet at, 3 graphs that meet at 1 point. My logic is going out the window. 3 graphs that meet at 1 point. No, 3 planes. 3 planes that meet at 1 point. 3 planes that meet at 1 point. That would be nice. That would be super duper nice. You guys see this? I guess, okay. Here's the solution. Pretend like these planes are our planes. And no, I don't want all due respect, Warehouse, I don't want to. Here's just one solution. Thank you, Warehouse. I appreciate you. I just don't want I just don't want a big lesson. If these planes were our planes, they're probably not. Now, our planes that correspond with us, our XYZ, an equation in XYZ, guys, is a plane. Now, our planes would probably be slanted differently than these planes, but they're analogous to these planes, okay? And they meet at 1 point, namely this point right here, and that point is located at the order triple. That point is located at the order triple 1/2, 2 and negative 5 halves, where x is the 1/2 is the x coordinate, the 2 is the y coordinate, the neg 5 halves is the z coordinate. Now, what does that mean? The the 3D Cartesian coordinates. Let me show you what that means. Those planes intersect. There's only one point where all three of those planes intersect, okay? There's only one point where all three of those planes intersect. And that point is located, like the origin, here's the origin, right? So those planes intersect where x is positive half. So you go to the right, and I'll credit due where it's due here. So you go 1/2 to the right, and you would go, well, I like my XYZ. Here's the standard XYZ. It's not as pretty as that one, though. Here we go. So for us, now here's the 0.345, but now that's not our point, though. Our point would be 1/2 coming this way toward our faces, 2 going rightward. So it would be here, right here on this little red line here. And then now neg 5/2 would be 5/2 down below. So you would go down 2.5. So it would be somewhere, maybe down here somewhere. That's how you would find it on the 3D grid. So you would go 1/2 in x in the positive sense, 2 in the positive sense in y, and then now negative 5/2 is neg 2.5 down below, straight down. But anyway, that's how you do it. But yeah. And here are planes that intersect along a line. Here are planes that intersect, well, actually, all three planes just intersect at one place only. Here, all three planes never intersect. Here, all three planes intersect at this line here and at this line here. There's so many things that could happen, it's not funny. Thank you to Dr. Dillon. And here all three planes intersect at this line. Here all three planes intersect at this line and this line. Guys, I could go on, right? Now, of course, we know that there's solvable equations. They just intersect at a point. They could do a line, none at all. Okay, here it's a line. Now here all three. Wait, no. Oops, I need to be careful. It's a line here. It's none at all here, because the purple guy here, or the pink guy and the blue guy never cross. My bad. I'm tired at this point. That's just common sense. The pink guy and the blue guy never cross, so all three will never cross because the pink guy and the blue guy don't cross. We want the place where all three cross, so they all three cross probably some line around here. Now here they all three will never cross. Here they obviously never cross. Now here they just cross at a point, like right here. These are the ones we like. And then here it's none at all, because the red guy, now like they all meet somewhere, but the trouble is, like when the red guy hits the blue guy, he's not hitting the green guy, and when the red guy hits the green guy, he's not hitting the blue guy. When the blue guy hits the green guy, he's not hitting the red guy. So yeah, all sorts of different ways these can pan out in 3D when you have like, this guy right here might be x plus, y plus 1/2 z equals 7 or something. Who knows? These are equations like ax plus by plus c equals d, right? All these equations are of that format. A plane is an equation of the form ax plus c plus by plus cx equals d. So just to reiterate that before I go for the day, a plane is an equation of the form ax plus by plus cz rather equals d, where a, b, c, and d are constants. Now the x, y, and z are variables. Now, okay. Guys, at this point, Our constants, and I better be a little bit careful, such that, and I better at least now I don't want to degenerate down to a line, such that at least such that A, B, and C. Well, if let's say A vanishes, what about if there's zero? If or let's just say a plane is A, B, and C are non-zero constants. Because zero, you're playing with fire. I don't want to go to lines, non-zero constants. Now, life gets hard if we start getting lines. If let's see, what if we have if A were if we took A to be zero, if we took A equals zero, then we would have, for example, then we get like by plus cz equals d. Now A could be, okay, A is zero, so we're pinned. Now x could vary, right? Then x could be anything. Well, maybe it doesn't matter anyway, but let's see. Then x could be anything, and we get by plus c to z equals d. Okay. Okay, and technically we have a line here, right? By plus cz equals d. That's the general form of a line, but we still have a plane because z could be anything. I claim that I don't have to restrain A, B, C, and D, or A, B, and C like that. So the equation of a plane in 3D space, I shouldn't have to restrain I shouldn't have to make the non-zero restraint. No, I don't want determinants. Equation of a plane AX. I know what it is, but my question is, do I have to restrain to non-zero? I don't think I do. I don't think zero. Okay. Let me visit like equation of a plane. Let's say that A, B, and C were all zero. Then X, Y, and Z could be. Actually, it would only be a disaster. Equation of a plane AX plus BY plus CZ equals D. Now, okay, it's just so it's AX. Don't worry about the calculus language. AX plus BY plus CZ equals D. Or constants or none. Guys, I don't think it matters, and it doesn't matter, because x could be anything. We get the equation of a line, but that line can lie anywhere. So we get the line by plus cz equals d, but this line can lie anywhere in the z plane, or in the x, This line can lie anywhere in the x plane. Or can lie, this line can, but x can be anything. So you're just going to have like what you would have is you would lie along. This would just be like you would have, what would you have? You would have x comma, and if you solve for y, let's just say b and c are neither one zero. You would have x comma y comma. And if you solve for z in terms of y, you would have d minus, you need to solve for z. So you'd get d minus by over c. D minus by over c. So yeah, I mean, you're still in a plane. You are still in a plane. But the rules are different. Now, I'll be honest, I didn't really cover all the cases. And likewise, so if just one of these guys vanish, A, B, and likewise and the analogous thing is true if just B vanishes or if just C vanishes. Now, if two of the guys vanish, now, you know, you're highly restrained. If exactly two vanish, then let's say A and B vanish, then CZ equals D. Z would equal, you would have a vertical line, but that vertical line could take on any X or Y value that it wanted. So that vertical line, so you could stretch that vertical line out. Well, let's see, you would have a vertical line. Now, it would have to take on those Z. Well, actually, no. No, that you wouldn't have a vertical line. You would have to stay at that elevation. But you would have to stay at that Z elevation. But that Z elevation could take on any X and Y value that it wanted because A and B are 0. So yeah, it would just be a plane fixed at that elevation. So it doesn't matter then either. You still have a plane if two of these guys vanish. Okay, now if all three vanish, you're toast. Okay, so I see. So now so the only restraint we need to make, I don't need to insist these be non-zero constants. I just need where A, B, and C are not all 3 0. I probably fussed about that too much. Okay, that's good. Yeah, because we at least want to, if they're all 3 0, we don't have a ball game to play. Okay, so that's good. Now at this point, let's go back to, wow, what a nuclear bomb of an assignment. Sorry, I probably shouldn't joke about that, but what an enormous assignment. Now, if you have something like okay, I didn't see number 31 coming. I'll have to cover 30 and 31 in another video. You're going to have to Gauss row reduce it like we just did in this video. Guys, number 28, you have to Gauss row reduce this, and you get a row of all zeros. And I'll save this for the next video, maybe. What time are we looking at here? It's 5:18. But now, if you have empty spaces, you have to put zeros there. Like this is 0x, and then you don't notice you have the fourth variable called w. You have to put 0w here. If there's empty tooth gaps, you have to put 0 variable there. Like this is 0w here. This is 0x here. Okay, so you have to fill in the matrix, right? You fill in the matrix like we did, and you do row echelon, and you'll go through the motions. You're just in several dimensions now. You know, instead of having a 3x4, you got a 4x5. You do row echelon, and guys, you do it. You want the main diagonal. You're going to want to try for the main diagonal to stay 1 as long as possible. It actually, though, as it turns out, what's going to happen to you when you do row echelon, you're going to get 1, 0, 3, 0, 0. Then you're going to get 0, 1, 2, 0, 6. But then you'll never ever get your, you'd love to have a 1 right here, but you'll never get it. But you will get a 1 right here. So what's going to happen to you is you're going to get, so what that W equals 0 decisively. But notice you don't get anything decisive for the other variables. We've got a bunch of planes in hyperspace that are crossing, that have dependency. So we have some hyperdependency. So what we have here, we have this is so x, y, z, w in the solution column. So we have 1y plus 2 z equals 6. So here it is, 1y plus 2z equals 6. And we have 1x plus 3z equals 0, because we just get 0 here in the solution column. But now, if you have but that's the same thing as x equals neg 3z. Okay, and what you can, okay, oh, they wrote it out here, didn't they? Okay, so we have these two equations. W is 0, so W is gone. W is toast. Now what you can do is you can actually plug, if x is neg 3z, you can sort of switch between x and z. Like you could, you can express, like you can plug, you can write x equals neg 3z, or actually you can write z is neg 1/3 x, plug neg 1/3 x into right here, and you can get y minus 2/3 z equals 6. That's a little funny, but that's fine. You may not want to though. So we have x equals neg 3z. We have y equals, if you subtract 2z over, y equals 6 minus 2z. Here we subtracted 3z over on this equation. We subtract 2z over here. We want to get, we want z to be our dummy call, our dummy variable, our dummy reference. We want z to, we got to have somebody to refer to. We can't refer to W because he was solved for. So we got to have somebody. Let z be that somebody. Notice z is in each of these equations. Z almost has to be that somebody because he's in each of these two equations. So we want z to be the dummy call. So we want z to be the independent variable. So what we do is we do x equals neg 3z, and we do, so x in terms of z, and then we do y equals 6 minus 2z. Where z is the arbitrary variable, that's sort of the dummy call, or the arbitrary. And now w, you can't help w. W is 0. So what we have, x, y, z, w, and where you express as many people, where if it's not solved for, you express it in terms of z. So x is neg 3z, y is 6 minus 2z, z is just z himself, and w is 0. You can't help w. So there's that. That's how you do a question like number 28. And questions like these are kind of funny. They're kind of strange. So you got, so neg 3z is x, 6 minus 2z is y. Now z is just your reference call. You put z himself for z. And then 0 is w. Okay. Now number 27, again, you'd want to use a matrix call. You could you could do it in equation mode too, by the way, guys, but that's kind of rough. I would probably do a matrix. I'd do it matrix form. You actually get a 1-point solution. You just do it like we did that the whole time. These cross at just 1 point. So namely, they only cross at 1 point. Namely, you get a perfect solution. 1/2 for x, also 1/2 for y. Z equals 5/3. And W equals 0. You just do it like we always have been doing it. Okay, that's cool. You got to do a 4x5 though, right? Now again, if you ever have decimals, multiply by 100, you'll get 75x minus, you'll get 75x minus 50y plus 25z equals 1,500. That's the price you got to pay. Now for this one, you only have one equation, right? You just have one equation. So the only thing you can do is you let y be y himself, you let z be z himself, and the only thing you can do, you just solve for x in terms of y and z, and just subtract over, and you'll get x equals neg y, and add over as the case may be, just Benedict Arnold, and you'll get x equals 21 minus y plus 2z. And they just put it in a different order. And indeed, yes, we have one equation and 3 unknowns. That's kind of funny, right? And like here, if you Benedict Arnold, again, you just solve for x in terms of y and z, you subtract over, and get 14 plus z minus y, but then divide everybody by 2, and you'll get 7 plus z over 2 minus y over 2. Now y is just y himself, and z is just z himself. Now this one is no solution. If you multiply this row by 2, you'll get, or neg 2 in particular, you'll get 2x plus 2x minus 1y plus z. So these two sides match. But you'll get negative 5. That does not match 3. The left sides match perfectly. The right sides are different. That always means no solution. Okay, and like on number 21, now you want to solve for y in terms of z. So these are infinitely many solutions. These are the same equation in disguise. So what you want to do is you want to de-gut x out, or you want to solve for as many variables as you can. X can actually be solved for. X is 1, and if you do row echelon on this guy, like if you add the two equations, notice if you add these two equations, guys, you'll get 4x equals 4. X equals 1. So what you have is, and if you plug 1 back in, you get 1 plus y plus z equals 4. But subtract 1 from both sides, you'll get y plus z equals 3. Okay, so y plus z equals 3. But then you want to solve for y in terms of z. So y equals 3 minus z, and z is just z himself. And then likewise for the others, that's how you do a lot of the dependence. And like on this one, x can be solved for directly, and then you solve for y in terms of z. Like you would have to get 20x. Well, no, actually, you just add these two. You subtract these two equations. Subtract the top one from the bottom one, and you'll get x equals neg 5. And then plug neg 5 in. You'll get on the bottom one. Let's say you'll get neg 25 equals 3. Add 25 to both sides. That's 28. Neg y plus z equals 28. So neg y plus z equals 28. But then just solve that, and you'll get y equals z minus 28. But z is just z himself. But no, on this other one, they want you to solve for y in terms of x. But you can get z is fixed. So this is a plane where z, where elevation z is fixed. So like z is like this would be a plane where you're flat at z, but y is but y and x depend on each other. In particular, so if x equals x, y equals x minus 7, right? So you're kind of, it would be like a y equals x minus 7. But anyway, it would have a certain, it would go along y equals x minus 7. Now z would be fixed though, wouldn't it? Well, actually, would this be a plane or would this be a line? Let me think. So y equals, no, this would be the line, y equals x minus 7, is equals neg 1. But anyway, yeah, because, no, z is fixed. So yeah, since z is fixed, this would be the line, y equals neg 7. But I mean, sorry, y equals x minus 7. My bad. Whatever your x coordinate is, y is 7 lower. So this is what the line y. This is the line y equals x minus 7. Down there, your z. You go to z equals neg 1, and then you stay on z equals neg 1, but you have to obey the equation y equals x minus 7. And like here, you go to the plane x equals neg 5. But you have to obey the equation. Now the y coordinate is 28 less than the z coordinate. you would obey the equation y equals z minus 28, and so on. I wish I had a grapher. And here, like for this guy right here, you would have visual stuff going on. Guys, I got to call it a day on this one. Have a good one. Bye-bye.